All right, guys, you got. We haven't really done anything new yet, right? I mean, we just did the number system stuff last time, so I'm going to assume there shouldn't be probably any questions from homework, considering we haven't done anything yet. Yeah, go us. Okay, so I want to show you something, a couple things that you might have never seen before. A lot of this stuff in the sections we do in Chapter 9, you should probably already know. One thing I want to tell you, this book makes it seem like there's all these perimeter formulas. There aren't any perimeter formulas, right? I know you probably know one. You probably know the perimeter of a rectangle, unfortunately, because you don't got to know that. What's the perimeter of any shape?
Length times width?
No, you're thinking area.
Oh.
Add up the sides.
Okay.
Right? That's the only perimeter formula you ever have to know. So unfortunately this book lists a bunch of perimeter formulas. No, there are no perimeter formulas. Don't make it seem like there's all these other formulas to worry about. You guys with me? Yep. Just add up all the sides. I mean, I could have this weird ass looking shape. Just add up all the sides. I don't have a formula for it. But area, we obviously, you guys better know. What's the area of a rectangle?
Width times width.
That's crazy. If it's a square, it's the same formula, really, just that these would be the same, right? So if it was a square, the area would be
Length times width.
Yeah, which in this case would be
X times X squared.
no way. Okay. It's amazing, right? So far, you're really happy you came today. New stuff. No. Who remembers the area of what I call a decapitated triangle?
One
Which you
half.
probably call a trapezoid.
Um,
Let me give you some stuff here. This is the height.
H, right?
Who to what? Oh, crap. All right, let's go one step back. Let's put the head back on this poor triangle, dude. So that's a decapitated. What's the area of this triangle?
1/2 BH.
Well, exactly. Cool. I like it. You guys with me?
Yeah.
All right, so this is all old news. I want to build up to the semi-new news. Taking a step back from this. This why is that 1/2 BH? Because what about parallelogram?
1/2. No.
So watch this. It's kind of cool.
Everything's 1/2.
1/2 is everything. If I took that triangle, chopped it, and put it here,
It's just a rectangle.
what shape is it now? Yeah, rectangle. It's got H by B, so the area would be HB or BH, whatever you want to say. Be careful, you go BH. You guys with me? So this idea, did you guys understand what I meant by chop that side off and put it over there? Do you guys see that? I kind of made it into a shape that I know. This is a cool idea. The weird thing is I was doing exactly this kind of stuff in my calculus class, at least at the beginning of the lecture, and then we got all weird. But I'm going to tell you the same thing I told them. If there's a shape I don't know the area for, I try to reorganize it into an area I know. Because if I just chop pieces off and put them back on, did I change the area? No, I didn't change the area. It's the same area, just moving stuff around. So this would then be, if the area of this parallelogram is H times B, and I make a triangle by cutting it in half, obviously the area of a triangle is 1/2 HB or BH, right? All right, you guys should know that already. I like it. How are we doing so far? Okay, cool. Now, the one that's really interesting, let's do this one first. Poor little dude, I'm saying you're not interesting, but oh well. If I don't know the area of a shape, I try to cut it or put it back together into a shape that I know. So here's what's cool. If I cut it right here, I just made two whats?
Triangle.
Triangles. I love it. And the height of both of them is H. What's the area? Well, let's call this triangle 1, and we'll call that one triangle 2. What's the area of triangle 1? 1/2
HB.
HB2. I like it. Does everybody see that? Is that cool? And what's the area of triangle 2? 1/2
H.
HB1.
B1.
Become an H. All right. I appreciate the sigh. So if I add those together, I get the area of the trapezoid, right? So the area of the trapezoid is 1/2 HB1. You can make an H, Jeff. There you go, buddy. Plus 1/2 HB2. Oh shit, here comes a little algebra. What's common to both of these? What can I factor out? H and?
1/2.
1/2. So I can take a 1/2 and an H out, and what's left?
B1 and B2.
This is awesome. Look at that formula. That's the area of a trapezoid, the area of a triangle. Triangle's only got one base. So it's got one base in its formula. Trapezoid's got two bases. So it's got two bases in its formula. Ooh.
Yeah, that's pretty common.
All right, cool, maybe.
Yeah.
All right, cool. So here's the one that'll really blow your mind a little bit. You should know the area of a circle, but I don't know if you know why it is. And this is the one perimeter formula you should know. And of course, for a circle, we don't call it perimeter, we call it circumference. So let's start here. Circumference of this circle is what?
Pi r squared.
No, you're thinking about area.
G diameter. Radius. Diameter.
Yeah, sure. I could take that. So it's either going to be 2
pi r.
or since twice the radius. What is twice the radius?
The diameter.
The diameter. So I can write this as pi times d. And real quick, do you guys know where, I love this question, do you guys know where pi comes from?
The oven.
I had you pretty much top my list for answering like that. Where's the mathematical pi? Where does that come from? That one, pi. So this is interesting. No matter how small of a circle I make, you guys doing your own thing? All right. No matter how small of a circle I make, or if I cut the earth in half and look at that circle, almost a circle, right? And this is what civilizations looked at throughout time. They said, when I take the circumference and I divide by the diameter, it's always coming out to the same damn number. That freaked them out. It would freak us out too if we saw that. Like, why is it coming out? No matter how big you make the circle, how small you make the circle, that ratio came out to be about the same thing. So the Egyptians had an estimate of 22/7. So if you do 22 divided by 7, comes out to be pretty close. You can try it. It's like 3.14 something, and then it kind of goes away. Right? What'd you get?
3.142857.
Yeah, so it's pretty damn good for Egyptians with no computers and shit, right? It's not bad. So that was their estimate. Other civilizations had other estimates, and nowadays we just let supercomputers just chug on it and just go out to the 18 billionth place or whatever. Pi was not invented, but thought of first, and then they just multiplied the d up and said, oh, look, there's a formula for the circumference. Yay. And they said, oh, diameter is twice the radius. There's another one. Yay. Do you guys understand? I don't know if you ever knew that. Did you know that? That's where pi came from?
I do now.
I like it. So in math, any number that we've given a special symbol to, it's because it came out of something. Just kept, like, I keep seeing this number. What the hell? So we gave it like E. Do you guys know E?
Yeah.
Like it comes after D. No, but in math, the E is used to model population growth, for example. Right? Throw some rabbits in a room, give them some food. Weight, population growth. Right? So that came out of all these computations. Like, they keep getting the same number, let's give it its own symbol. So E and pi are pretty much like the same idea. Okay, cool. I like it. Maybe. Okay. So that's the circumference. So how do we get the area then? And I know most of you guys should know the area of a circle, but I'm going to show you where the hell it comes from. This kind of gets cool. If I cut this bad boy in half, right? It looks sort of like, go keep the paper. How far is this?
180.
Yeah, all right, so quick word about degrees. Degrees are completely made up. Do you know that? Humans just made it up. They said, you guys, that doesn't mean that it's not useful. Doesn't mean it's not useful. What about the fact that right now it's almost 3:45? That's made up. Ain't it made up? That we just said, let's use 24 hours in a day. Why not? I mean, it's made up. But is it useful? Yes. Degrees. Why are there 360 degrees? Because I can break 360 up into a lot of factors. That's really it. Right? You kind of with me? A little bit? A little time? Okay. So degrees, I'm not talking about degrees. All the way around is how far? All the way around is how far?
Pi. R.
2 pi r. Right? That's the circumference of a circle. So how far is this?
1 pi r.
1 pi r. I love it. Just cut this in half, right? I like it. All right, you guys semi with me so far. So if all the way around is 2 pi r, halfway around is pi r. Okay, good. So stay with me. This is kind of cool. All right. See if you guys are with me. So if I cut the middle, and then I cut out to the outside, but I didn't cut through. All right, stay with me. Stay with me. This is kind of cool. If I pick that up and open it, it's going to look like that, basically. My beautiful drawing, I know. Do you guys see that? If I pick that up and open it, there, it looks like teeth, right? Oh. If I do the same thing to the bottom and fit it in, so I do the same thing and then it's going to look like that. How long is this? That came from this. How long is this?
Pi r.
Pi r. How tall is this?
R.
R. What's the area of that rectangle I just reorganized my circle into? Holy shit. Right? The area is pi r squared. Has anybody ever seen that before? I can't remember this book. I think this book is one that actually does that. I've never seen a book do that. Was it this book? No, screw you, book. It's too bad. Oh well. That's kind of cool if you let it be. Anybody, I mean, no? The crowd goes,
That's pretty cool.
Thanks, man, for that.
Shape-shifting.
Yeah. The idea is, if I don't know the area of a shape, I reorganize the shape into an area I know. And then I can make a formula for it. We did that with this, and this is just a little more interesting application of that. Kind of freaky. All right, nifty. Okay. What else in there? So section 9.3 is all about perimeter and area. So for example, if I said, find the area of this, become that. Let me give you one that's Sure. Oh, that's even. I like it. That should be 28.5 ohm. So what's, this is chapter 9. Comes right off of chapter 8. All right, so then in chapter 8, what do? We talk about different units of measurement. So probably the first thing you want to do is make sure that all your units are the same. There you go. And what's unit up here is not? Feet. So how many inches is that?
24.
24. Cool. Now you can attack this. What's the area of this going to be? What's the area formula for a trapezoid?
1/2 h times b1 plus b.
Kick ass. So it's just like a triangle, except you got to have both bases in there because there's two bases. So now you just got to plug and check. What do you put? What's the height?
24.
24. And the bases?
5.
5 and 19. Whatever the hell that is.
12.
280. Is anybody else doing it for me?
288
288, yeah. 288 what?
inches.
Inches squared.
Square inches, right? Area. In fact, 24 is in inches, right?
Yeah.
And each of these are in inches, so it'll be inches times inches is inches squared. No big deal. Multiply something by itself, it's that thing squared. That's why it's square units. So when I measure area, it's always square units. When I measure volume, it's going to be cubic units. Kick ass. It's not too bad. I mean, the only thing you got to watch out for in this section is when they give you parts of it in different units. Just look at it first before you start throwing it into a formula. What's the perimeter of this?
Add up the size.
70.
75.
74, yeah. Cool. Just add the sides. This doesn't come into play, right? Because it's in the middle. You want to say Johnson walked the perimeter, and if he walks there, you're like, all right, dude, you're fired. Just walk the freaking perimeter. That means walk around the thing, right? Maybe. So nothing major yet, right? So this section 9.3 should not be anything major. This is not where the majorness happens. The majorness happens in the next section. We talk about volumes. Because you normally don't do much with volumes. One last type of problem I want to show you is they ask you, for example, here. Yeah, so let's see. I like it. So what's the area of the shaded region, right? Do you remember these kind of questions? Oh, yeah. So I always call this kind of problem, I call it a cookie cutter problem, because you look at it like, before I cut, what did I cut out? What shape did I cut?
A circle.
A circle. And what was it before I cut it? It was a whole trapezoid. So figure out the area before I cut, minus the area that I cut, and it's going to be the area of the shaded part, the area that's left over. The dough that you have left after you cut this big-ass cookie out, right? Cookie and pie, oh shit. It's going to be dinner. So what's the area of that trapezoid? Well, what do you need to know about the trapezoid that they don't give to you directly? The height, but they kind of do. How tall is this trapezoid?
8 inches.
Why is it 8 inches? Because it's equal to the...
Yeah, the diameter.
Cool. So the area of the trapezoid, 1/2.
1/2, 8.
8.
20 plus 9.
20 plus 9. Cool. So that's the area of the trapezoid. I'm getting less reaction from you than normal. This is awesome. This should be basic stuff. I'm sure you guys are all like, all right. Hopefully you're all like, oh, okay, Jeff, something new would be nice. No? Is that not what's going on? So, does it make sense what I'm trying to do with this problem? The problem is asking you the area that's shaded. So what you do is you take the area as if the whole damn thing was shaded, and then you subtract the piece that's not shaded. You cut that piece out. That's why I call it a cookie cutter problem, right? How are we doing? So then what do you get for this?
4.
So what's
What'd you
sorry.
say?
And then,
The whole thing, 116, right?
yeah.
116.
Oh,
Inches squared.
Good, because everything was inches, thank God. Now, how do I get the area that I cut out? It's just a circle. So,
116 minus the area.
area of the circle is what?
pi r
25
squared.
And what's r?
4.
4. So it'll be pi times 4 squared.
I got like 50.26.
Sure, because 16 times 3 is like 48, so 16 times a little more than 3. 50 point who what?
0.26.
So then the area of the shaded part will just be the difference in those two, right? So you cut that piece out. So it's awesome. Those parts are just subtraction. You're cutting that piece out. Okay, is that right? And then whatever the hell that is. 65.74. Pie and cookies. Yeah. No? Okay. So let's talk a little bit about volume. And then I'll let you guys out of here nice and early. If that's all right. See if that perked you up a little bit. You're like, early? Excuse me? All right. I thought something might perk you up.
I feel like getting like a milkshake. I'm done. Let's go.
What's that? Oh, thank God. I don't have to look at you that far. Okay. I'll let you out a little early, because that lets me out a little early. I don't know if you guys realize it. All right. So, let me start this out. Oh, sure. So the area of this rectangle, of course, is length times width. So, do you remember, do you realize back in the day we had these things called records? So if I knew the area of one record and then I stacked a bunch of them up, the volume would be the total amount of space that all those records go through as I stack them up. So it would be the area of a record times how tall the stack is. So it's a repeated shape, right? So anytime I have a shape, a three-dimensional figure, that's really just, now for me, that is amazing. The picture is amazing. So if you don't like it, it's too damn bad. It's really good for me. So it's that rectangle on the bottom is repeated this many times. So the volume is going to be LW times H. Anytime I have a shape that's repeated, I get the area of the shape times how tall or how long it is if it's laying on its side. You guys kind of with me? So most of you should have known that the volume is length times width times height. You do all three dimensions together for a rectangular solid, maybe a box, if you want to call it a box. So taking what I just said, what about a cylinder? Which is a bunch of DVDs stacked up. There you go. Is that more modern DVDs? My records and my 8-track tapes.
Records are making it from that.
What's that? Yeah, they are. Yeah, you want to listen to that vinyl. You want to get that real sound, that crackle.
So would it just be pi r squared, but like repeated?
All right, so the repeated shape is a circle.
Yeah.
So let me give us some dimensions here. That's H, that's R. So the area of the base, which I'm going to call big ass B. All right, little b is just the base, like a length. Big ass B is an area of a base. Are you with me? You're like, whatever, man. You're the teacher. Whatever the hell you want to say. So what is the area of the base?
Pi r squared.
Pi r squared. And how often is that repeated?
H.
H. So the volume in general of anything that's a repeated shape is the area of that shape times the height. Or again, like the length if it's laying on its side. That's beautiful. No matter what shape. If I made a triangle down here, like a Toblerone. Anybody have Toblerones? Know what Toblerone is?
Yeah.
Pup tent? Toblerone. Okay, a lot of you guys know Toblerone. Good. Now I need to get Toblerone freaking on. So I take the area of the triangle times the length. That would be the volume. And let me call this big ass B like I want. The area of the base times the length is the volume. Area of the base times the length, in this case I call it height, is the volume. That's beautiful. I don't have a billion different formulas to memorize. I have one that works for any repeated shape. Too amazing to believe. Maybe. So this formula, if you really want to see it full out, it would be pi r squared H. That's the volume of a cylinder. Cool. I like it. I like it. So here's the last thing I'll talk to you about. And I'll let you out like stupid early. Don't get used to it. Look at you guys like, what? I am also being nice to myself, just to remind you. If I cut a cone out of this thing, and a cone is the simplest example of a pyramid, believe it or not. A pyramid is defined to be all the corners of the base come up to one point. Well, my base is a circle, it'd be all the circle come down to one point. Do you guys kind of follow? Here's what's cool. This is what's difficult to see in a 2D picture like this. But the empty space is not just here, it's all the way around it, isn't it? If I cut this cone out, there's empty space all around it. So what ends up happening is there's twice as much stuff here as there is here. So the volume of a pyramid, in this case the cone, is always going to be 1/3 the volume of what I cut it out of. That kicks ass. So it'll be 1/3 pi r squared H. Right? I just lied to you because I'm going to do one more. Because I got the picture right here. So watch, here's another pyramid. If I take every corner up to one point, and even I suck at drawing, but would you guys agree that is a freaking pyramid I just made? Can you see it? You don't even have to like cross your eyes or shit with the magic eyes. You guys see the pyramid? Yeah, lots of it. But give me a break. That's me. It's really good for me. The volume of the whole thing is LWH, so the volume of the pyramid is 1/3 LWH. Always. That's awesome. So then whatever shape it was, if it's a repeated shape, I make a pyramid out of it. It's 1/3 of what it used to be, 1/3 of the whole thing. So any pyramid basically is 1/3 big ass B times H. 1/3 the area of the base times the height. So what we'll do next time is we'll focus on that section. We still got to finish out some stuff. But I think it's plenty for today. I'm tired. Yeah.
Are we gonna get into stuff that isn't the same shape repeating as the height?
Yes. Yeah. For example, like a sphere.
Or like a vase? Or like
No, it's real. The minute the shape gets difficultly defined, like a vase where it might be bulbous in the middle or something,
and then it thins out.
you actually need calculus to do it.
Oh, it's nothing that's gonna fluctuate.
No.
Yeah.
All right.